Welcome to Tree Talks, Talks with the Tree Whisperer. Your host, Kevin Lee from KRL Tree Service, brings a lifetime of tree work experience and a solid foundation in botany to every episode. Welcome and enjoy.
Good morning, tree lovers. It's Kevin Lee in Calgary. It's 20 below here, so it's a good day to be inside and talking trees. This is Talks with the Tree Whisperer. This is our fourth episode. We're going to continue our discussion about meristems. Episode 3 was about the ram apical meristem, how roots extend through the soil and how they continue their growth of non-woody roots. This, as I said, is number 4. We are going to deal with a different meristem called the SAM. This is the shoot apical meristem. The shoot apical meristem is responsible for all of the growth and changes in width and height of a tree. The only way that the tree gets taller is by extending its shoots. That happens once a year. And that is all that the tree can do to get wider and bigger. You add up 10 inches or 15 inches or 3 feet or whatever the average annual growth of your tree is, and times many years. And yes, that's how we get a big tree. Once the shoot extension is finished growing later in the summer, that section of growth stays exactly in that place, in that physical space forever, as long as that tree is still intact. There is no expansion, stretching, anything like that. So it's almost like a wall of bricks or something like that, various steps. And each brick was 1 year's growth. If there was lots of water, we'd have a nice, thick, healthy brick. And if it was a dry and miserable year and very hot and the rains didn't come and no one watered the tree, the bricks would be very, very thin. So anyways, that's just a little overview of this. We start with the terminal bud. At the end of every twig, manufactured last year, and we're going to get into the process of how that is done, but manufactured in last year's growing season is the terminal bud. There are lateral buds on the shoot also, but it's the terminal bud that does most of the growth and is going to be responsible for the initial extension of the shoot. At the very base, inside the bud, if you ever open up a bud, you'll notice that it's sort of a lot of growth actually happened. The initial growth, the startup procedures, let's say, happened in the previous year. And if you actually open a dormant bud, you will see that there is some juvenile leaves in there, and they form around a mound of tissue that is the actual terminus of that bud, and that is going to stay the terminus of the shoot. There is just like in the ram, there is this magic tissue that, again, I get excited about and I find so amazing. These tissues that can constantly, through the process of mitosis, split off and constantly make daughter cells, adding more and more and more tissue. And this is the only way that trees get bigger. We add more tissue at the ram, we add more tissue at the SAMs, and we add more tissue at the vascular cambium and the court cambium. Those are the 2 next episodes we're going to deal with. This is how trees grow. A tree has to grow. When the cambial sections or meristematic parts of the tree are dysfunctional or damaged or die, that is close to the end of the life of that plant, whether it's a redwood or whether it's just an annual. Everything plants just have to grow to live. So it's a pretty amazing system. In between those juvenile leaves in the bud, as I said, is this sort of mound of tissue that is the terminus of the shoot. Hidden underneath there, the magic zone in the meristematic zone in the shoot is called the tunica corpus. And it is just this layer of meristematic cells initials, as we spoke of. Initials are mother cells that constantly produce daughters through the cell division process called mitosis, and they are going to grow the whole shoot. The fascinating thing, and I will explain this in a couple of minutes, but the fascinating thing is this magic. Gotta quit using that word. I'm sorry. This amazing tissue, the tunica corpus and the meristematic tissue itself, always stays at the tip. And so, just to jump ahead a minute, because it's good to say this right now. During the shoot extension's first week or two, whatever kind of tree you have, if you were to just go outside and just grab one of the new little branches and look at this, what you'd plainly see is you would have a shoot in your hand of some length. Closer to its origin point, and there would be a bud scar there. This is a little ring of tissue, a mark that's going to stay in the bark for a while. This is called the bud scar. This is where the end of the growth that made the bud last year and the new growth this year from that bud is it's a junction point, and there is a physical mark in the twig, a little ring that goes all the way around. So if you start at the tip, you would have the very tiniest little, very, very small leaves, just a couple millimeters or a millimeter across. Couple inches back, you'd have 3, 4, 5 millimeter sized leaves. A couple centimeters back again, you would have 8, 9, 10, 11 millimeter sized leaf, and on the way back. What this plainly shows us is that from the bud scar to the very terminus, it's a physical representation of the age of the growth of that twig. The tissue closest to the very tip with the micro little leaf that's just appeared and is expanding has to be younger than the larger leaves back behind it on the stem. What this tells you is that the meristematic tissue stays at the very growing tip, and as it produces new cells, it lays them down behind. So it's sort of like taking a pencil and moving it across a piece of paper. The pencil tip is the meristematic tissue, the tunica corpus. And behind that, the youngest and then a little bit older and a little bit older again leaves are showing the change in time since those little leaves were generated and the most current little tiny leaves are. So that's a physical proof that you can see how the meristematic tissue itself stays out at the very tip, lays down tissue behind it. Yeah. Again, with the similar, this is very similar, but with slight modifications to some of the discussion we had about the RAM. So the meristematic tissue at the tip, as it pushes out and grows and adds new cells, quickly differentiates into 3 sub-meristems, okay? So we have the protoderm. This means first skin. Derm is dermis, epidermis, the outer layer of the, it's not bark yet, but we could call it that, but it is not bark yet. That's the protoderm. The ground meristem is going to grow the tissues inside that. These all 3 of these differentiate and start growing the shoot as we know it, a twig. So the ground meristem is going to be responsible for the formation of the pith in the middle and the cortex material, which is just the ground tissue, lots of parenchyma cells that can store energy. On the inside is the procambium. That's the 3rd section of the submeristems. The procambium will grow the xylem and the phloem tubes that are together in one. Think of a circle with a line through the middle of it. One half is xylem, one half is phloem. One half is connected to the greater tree system below, to the xylem, where that's the water and mineral system, bringing water into the new shoot. The phloem is the sugar distribution tubes. They are together initially in primary growth here in the shoot. Okay, so those are the three meristems. The older tissue, as I mentioned, is always behind. And you can prove that by looking at the age of the little wee juvenile leaves. That's, yeah. So the shoot extends and we get auxiliary buds are forming. There's three main patterns. So if you look at most trees and shrubs, you'll see that the nodes and these where the leaves form is in three main patterns. When they are staggered in steps, so to speak, on opposite sides, that's called alternate. So we have one here and one here and one here and one here. That is alternate, okay? Opposite is when we have two leaf traces here, two leaf traces here, and two leaf traces here, okay? And the third most common one that you'll see in almost all plants will fit into one of these patterns is whorled. And I'm trying to hold my hand level here and show you that if we had the stem, we would have a group of leaves at a specific point and then above another. And that's whorled. That's how a spruce tree grows, with whorls. So those are the three patterns, the three main, most common patterns of the leaf formation on new shoots. Yeah. So the leaf trace will develop. This is the to function as a leaf and be separate connected, but separate from the new shoot. The leaf has to have all of its connecting tissue in place too. It has to have what's called the leaf trace inside. So this is a branching off of the xylem and phloem tissues and supplying new xylem phloem tissue for the new leaf. That happens very much as the new leaves are forming, and so that they can act independently, let's say, or at least be now an integrated part of that system, but yet be separate. I mentioned turgor pressure. Turgor pressure is all about new cells having lots of water availability. The vacuole, the water movement and storage organelle, in plant cells, in living plant cells, is like a balloon. The cell wall is like a shoebox. This is just a good metaphor for us to think about this. So we're going to make a square cell or a rectangular cell like a shoebox. Inside there is a balloon. If we really pump up that balloon and it's pushing firmly against, and it can occupy the vast majority of the volume of the living cell when water pressure is high. We call that pressure turgor. When this is a brand new cell that's just formed, it's a daughter cell, and it's just formed, if turgor pressure is high, as that cell runs its program development, if the turgor pressure is high, that cell will expand to its greatest capacity. And that is really what we want to do. During this time of shoot extensions is a really good time to make sure that your trees are watered well. Why? Because we will get longer shoots, we will get more leaves, we will get more mass, and we will be able to produce more sugars through all of those leaves. And in general, we will just have a stronger, more vigorous, and healthy tree. Okay, so that is a really important aspect of caring for your trees on your property. Yeah. Inside, we have the pith, and this is an amazing tissue in woody stems. Even a 100-year-old tree has that little wee ring in the very center. When you start counting all those growth rings, that's what you start at. There's a space there where there's no other ring on the inside. That is the pith. That is takes us back to some of the growth that we just described about the shoot extension, the differentiation of tissues, and the storage of energy, the parenchyma and the cortex, and the pith. That will be present as long as that branch exists. The xylem and phloem in a new shoot are not like in older parts of the tree. Initially, the xylem and phloem tubes are distributed in a ring, let's say. So if we started at the inside, we would have the pith. Then we're in the cortex, the living working tissue, the mass of the new shoot, all of its volume inside its epidermis, its new baby young bark. And then the major other function would be the xylem and phloem bundles. This is a crazy metaphor for this, but it's a pepperoni pizza. Yeah. So we're looking at a pizza, and rather than having the pepperoni all over the place, just at the inside edge of the crust, all the way around the outer edge of that pizza is going to be slices of pepperoni. So now we have a large circle with a ring of little circles just inside the edge. Okay. Those slices of pepperoni, those little circles, are divided in half, and half of them is xylem and half of them is phloem. Again, water up and nutrients in the xylem, and sugars being distributed in whatever direction they're needed. Typically, during the time of shoot growth, the shoot would be importing sugars. So not only would we have upward movement of water and nutrients, that's pretty simple and basic. The new shoot and the new leaves got to have water. But what people don't understand is, or at least it's a complicated process. Movement in the phloem is not just, from source to sink, from leaves to roots. That's the old system, the way that people would try to simply explain the vascular and fluid movement systems in trees. It would be up the xylem, down the phloem. That is a little oversimplistic and doesn't really give the phloem credit for its diversity and ability to supply sugars wherever they're needed. So when we think of the phloem, and I will speak at length about this in another episode, but I just want to talk about this because we're still inside that shoot, in those vascular bundles. We have a tremendous need for energy because of the constant cell expansion. At the very tip of the shoot, of course, the meristematic tissue, tunica corpus, stays in place, lays down new cells behind it, and keeps pushing out. Okay. And as those cells, that process and the cell expansion process requires a tremendous amount of energy. And so where's that coming from? Well, it's coming from other existing sources of energy stored in the tree's tissue. It would be in parenchyma, all over the tree's body. Again, the symplast, the inner connected living system. And it communicates very well and says, we need a whole lot of energy here on these shoot tips right now. So can we just concentrate on that? And wherever the tree senses that energy is needed, that's where it goes. And it's the phloem that supplies it. So we can move sugars laterally across in the branches and trunks of trees. We can move upwards. We can move downwards. Wherever the demand is, that's called a sink. And the source, of course, is sugar produced in other leaves and or lots of living parenchyma in the rest of the symplast. Okay, so we're getting pretty close to the end of this. We don't have to spend all day on the shoot apical meristem, but I do want to talk about one final aspect of its development, which is very important. Again, this is very similar to what's going to happen in the ram, but it is, all of these are subtly, and there are subtle differences, and I think they're interesting and worth describing. So what's going to happen is, as the season rolls on and the shoot starts to get woodier, the lignin is developed in some of these cells, and it's stiff and it can hold itself up against gravity, and it has good, strong leaf attachments there. We have the leaf trace coming out of the shoot, supplying the water and nutrients and sugars that the new growing tissue develops. We would have buds again forming in the axis of those nodes of those first initial leaf growth. Those buds can be activated next year and continue this whole process on and continue to just widen out and expand and expand and expand. It is just an amazing process. So let's go back to the pizza for a second and think about those slices of pepperoni. Inside there, as I said, is half of that is xylem tissue and half of that is phloem. As the season starts to get to its end, subtle changes, and these are all affected by growth hormones. We will speak of hormones later. That gets pretty complicated, and we don't need to spend a lot of time doing that. But just like your own body, so many processes are run by a number of different hormones, and it's the same thing. The main growth hormone, just to bring up one of them, is called auxin. And this is the one that is responsible for, it's kind of interesting, it's responsible for the controlling of so much growth, but it also can control the inhibition of growth. That's what keeps a shoot growing faster than any of its laterals. Anyways, the pizza slice and with a piece of pepperoni, okay? So later in the season, what's going to happen is the division and the walls inside the little slice of pepperoni that separate the two tissues are going to start to break up, and they will reach out to their neighbor, to the slice of pepperoni beside them. The slice of pepperoni, of course, is the vascular bundle, which contains the xylem and phloem materials, the tissues. Okay, so they sort of break up and they start reaching out. So what happens is we have the first early development of what's going to be its vascular cambium. Okay, so the phloem sides will, the skin, let's say, of the vascular bundle will break up. It starts to sort of unwrap, and rather than being round, it sort of starts reaching out more on a flat plane. And we have the phloem to the outside of that, the xylem to the inside. And what will happen is that tissue that was wrapped around the bundles is going to form the new vascular cambium. At that point, the shoot can now perform in its second year secondary growth. And this is how most of the body of the mature tree works, is by exhibiting secondary growth. So we only have primary growth in the tip in the first year of that shoot's growth. Afterwards, it's now 2, 3, 4 years down as the time has rolled on. We exhibit primary growth only at the tip, secondary growth in all other parts. Once the shoot extension is set, it's finished growing for the year. It will never change in length. It can't expand anymore. That process is done and it cannot be brought back. It only happens again next year at a terminal bud. So that is most of what I wanted to say about the shoot apical meristem. And what does that leave us? Well, that twig has grown. If it was an apple tree or some other types of plants that can have 2 growth flushes, they sort of have a really good early one here in Calgary in end of May, start of June. You can have quite a good rapid shoot extension, and then it'll sort of rest for a while and sort of, just stabilize and grow and continue forming up and getting woody inside. And a lot of times they'll take another shot at it, and we will get another extension. This does not form a separate bud scar, as I explained earlier. It's just sort of a rest period, and then the second flush can happen. Not all plants do that. Not all trees do that. All evergreens in this part of the world have a single flush, and that's it. So they grow from about sometime in June into July. 3 to 4 weeks is it. And if you've watered the spruce trees really well, as an example, you can have really good shoot extensions. On a young tree, the leader, the terminal shoot of the top of the tree could have grown a foot or even a foot and a half. So anyways, I hope I went from terminal bud through the growth process and back again to terminal bud. As I said, that's about all I need to say about the SAM, the shoot apical meristem. Thank you very much for listening. And in our next episode, number 5, what we're going to do is deal with the mother of the whole trunk of the tree. One of my favorite tissues, just because it's so physical and literally makes the tree. And that is the vascular cambium, which grows the entire trunk. So thank you very much. We'll see you next episode.